Okay, so this lecture is meant to introduce you to the idea of free fall motion. So far we've been looking at things that are just moving horizontally, and now we're going to investigate what happens when things are actually moving vertically. So free fall motion is defined as when an object is moving in the vertical direction and is only under the influence of gravity. And for right now, we are not taking into account the effects of air resistance. So we are still living in like a whiteboard land and saying we don't have any air resistance. The only thing that is affecting the movement of my object as it moves vertically either up or vertically down is gravity. And so gravity has a particular acceleration. So if we neglect air resistance, gravity is going to cause the object to accelerate at a particular rate. No matter how heavy it is, if there's no air resistance, the acceleration for an object vertically is always going to be a constant value. We're going to call it AY, and that value of AY is negative 9.8 meters per second squared. So that is the value of gravity, assuming there's no air resistance and the object is moving vertically. Okay? And notice it's a negative. Direction definitely matters. And anything that is moving up, we're going to consider to be positive, and anything that's moving down, we're going to be considered negative. So upwards movement is going to have a positive delta y and a positive velocity, and then the opposite's going to be true. That downwards movement is going to have a negative delta y and a negative velocity. And so that's something that the problem may not explicitly say, but that you have to be able to interpret. You have to be able to say, oh, it's moving upwards, I have to make the velocity positive. Or, oh, it's moving downwards, I have to make the velocity negative. Okay, so that's something that's going to be kind of tricky that you need to kind of remember, is the fact that direction matters. So let's look at this idea of gravity or acceleration in the y direction as being negative 9.8 meters per second squared. And what does that physically mean? So if we were to kind of look at an example of throwing an object upwards, and so I have drawn my little person there, and they are going to throw this object upwards. And for right now, we're going to look at the object going straight up and straight down, but it's hard for me to visually draw that on the board because it's going to overlay. So this is my movement up, and then we're just going to have to think of this is my movement being down. Okay? So let's pretend my person here who's throwing the ball is amazing and can give it an initial velocity of positive 19.6 meters per second. They're that good. They can give that exact same velocity when they're throwing it upwards. So the initial velocity is positive 19.6 meters per second. And remember, gravity, the y acceleration is negative 9.8 meters per second squared. So what does that mean? That means every second, that's that per second. So every second, the velocity is changing by negative 9.8. meters per second. Remember, accelerations are a change in velocity. So if my y acceleration is negative 9.8 meters per second squared, that means every single second my velocity is going to change by 9.8 meters per second. So if my little person here was able to throw that velocity, or that ball, with a velocity of positive 19.6 meters per second, and 1 second later, so this is going to be at 1 second, we'll say this is at 0 seconds, so at 1 second, in that interval of 1 second, my velocity should change by negative 9.8. So if I started at positive 19.6 and I'm going to change by negative 9.8, that means my velocity right here is now dropped down by 9.8, which is conveniently 9.8 meters per second. Okay, another second goes by. In that 1 second interval, my velocity is going to change by negative 9.8 meters per second. Like, that's what gravity does. It changes your velocity by negative 9.8 meters per second every second. So if I started with a velocity of positive 9.8 meters per second, 1 second later my velocity is going to be 0. And this is now at the tippy top. This is what's called the maximum height. And at the maximum height that an object travels, at the very tippy top, for a split second, that velocity is 0. So it takes 2 seconds for that ball to go upwards and reach its max height. And so right now its velocity is 0. Okay, remember, this is just the overlay of the downward movement. So the velocity is 0. 1 second later, so here's 3 seconds. 1 second later, my velocity still has to be changing by this rate. That acceleration is constant. So if my velocity was 0 and my velocity is going to change by negative 9.8 meters per second, what that means is right here my velocity is going to be negative 9.8 meters per second. And then 1 second later, so I'm down here at 4 seconds, my velocity is going to have to change by another negative 9.8 meters per second. So again, let's walk through it. I start at negative 9.8. I'm going to change by negative 9.8. So I will now be negative 19.6 meters per second. So look at the symmetry of this. Gravity is affecting this thing consistently. It's consistently changing the velocity by negative 9.8 meters per second. So if I start at 19.6, it's going to go down to positive 9.8, it's going to go down to 0, it's going to go down to negative 9.8, it's going to go down to negative 19.6. You can imagine if there was a huge hole in the ground, or if this guy's standing on a cliff, and it was 5 seconds later, I would change by another negative 9.8. Gravity is always changing the velocity by negative 9.8 meters per second every second. And so you could kind of just count it out and figure out, well, what's happening to your velocity, but we're going to use our kinematic equations to tell us what's happening to our velocity. But there's another kind of thing I want you to notice about the symmetry, in that the time that it took to go up, 1 second, 2 seconds, is the exact same time it takes to come back down to the original height. Another thing to note about the symmetry is that if it leaves the hand, or if it leaves this guy with a value of positive 19.6 meters per second, and it comes back down to the same height, the velocity is negative 19.6 meters per second. So there's quite a bit of symmetry when you throw an object upwards. And so let's summarize that symmetry. So let's kind of make a statement that says when an object is thrown upwards and returns to its original height, there's going to be a few truths that we are going to know. Okay? So when an object is thrown upwards and returns to its original height, something that we know is the time it takes to go up. So the time to go up equals the time to go down. So we could write that as t up is equal to t down. Another way we could write that is that the t total is equal to 2 times the t up. Okay. Something that we saw was that the final velocity when it reaches the starting height is just the negative of the initial velocity. And we could write this in terms of an equation that says that the final y velocity is just the negative of the initial y velocity. And the other thing to know that we didn't necessarily talk about when we saw that example is if it returns to its starting height, the delta y, the displacement in the y direction, is 0. So it returns to its starting height. Delta y is 0. And that kind of makes sense, right? Delta y, or displacement, is from start to finish. So if this thing goes up, then comes back down and lands back in my hand, it started in my hand, it ended in my hand, my displacement is 0. Okay? Now, in terms of the equations for free fall motion, they are the exact same equations that we have been studying, those same 3 kinematic equations. The only thing is we're going to be a bit particular and include y's. So the first equation says that v final, and I'm going to be specific now, v final y is equal to v initial y plus a yt. So it's the same equation, I'm just adding a subscript to denote that I'm talking about the vertical direction. And then the second equation, again, should look familiar. I've got delta y instead of delta x, and it's v initial y times t plus 1/2 a y t squared. And then the last equation, again, we're just going to add some subscripts. V final y squared equals v initial y squared plus 2ay times delta y. And the one thing to know, okay, so the video cut out, but here's where the important part is. The thing that's to remember, for any time you have movement in the vertical direction, the vertical acceleration, AY, is always going to be negative 9.8 meters per second squared. Like, that is always a known. It's never going to tell you in the problem, oh, by the way, don't forget to remember that the acceleration for the y direction is negative 9.8 meters per second squared. It is something you need to just know, that anytime an object is moving vertically, this is the acceleration. Always, 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 always. Okay? So when we get back to class, we will go through some example problems of free fall motion.